last 2 years plus, and today, as you said, is my 25th talk to this platform. I've tried to cover many techno-economic issues which are presently sort of engaging our government, and there are challenges in the solutions. So whatever they are doing, I'm putting across to you in a very simple manner so that you are aware of these challenges which are facing us. Today's talk is on bioeconomy. And I think many of you may not be familiar with this term, bioeconomy. So I will put it very simply in my presentation. But I want to tell you that bioeconomy is gathering extremely important status world over, especially in the last 10 years after climate change has been noticed. Many solutions are being talked about world over, and one of them is following the bioeconomy route. So we will go through that route in my presentation. And then the last, I will come to what is this Bio-E3 policy, which has been promulgated by our government about 4 months back. What does it plan to do? So with this, I will upload my presentation. Are you able to see my presentation?
Yes, sir. It's coming. Yes.
Right. So I have studied this issue, and I feel the new policy will boost our bioeconomy. But before that, let us just understand what is bioeconomy. Can you see this simple slide? Economy of a country requires input resources, and output will be products. Products can be in industry, products can be in agriculture, product can be in the form of services, but they require resources. This is a simple model of an economy functioning, and the output of the economy is normally called the GDP, which is divided into industry, agriculture, services, etc. Now, within this economy, there is a small segment called bioeconomy. So I'm going to introduce that now. You remove this resource, which is coming to the economy, and make sure it is a biological renewable resource. It can be, I'll give an example. It can be leaf of a plant, a medicinal plant leaf. If that is coming as a resource into the bioeconomy, the laboratories are able to make medicine out of it. The output is medicine. Input is medicinal plant leaves. Similarly, it can be the wood of a tree, which is being used by bioeconomy process, and the output will be some wooden product. It can be furniture, it can be for school, it can be for hospital, whatever it is. So bioeconomy essentially means you will be using biological renewable resource. It can be on land or it can be in water. It can be at sea. Take the case of fish. Fish is a biological resource. And of course, it is being consumed by people all over. But if you make fish oil out of that fish, then that product is a bioeconomy product because the input is renewable resource. Similarly, it can be dried fish. It is again a bioeconomy product. So bioeconomy essentially identifies a small segment of the overall economy. And the important thing is you don't use any resource which is chemical or which is fossil fuel natured, etc., etc. You are using items available in nature itself. Therefore, bioeconomy protects nature more than what the normal economy, which has got many adverse impact on the nature. So let's go forward. Let's come to the introduction. This issue has come to light in 2015 when UNO promulgated Sustainable Development Goals for this world. Normally, it is referred as SDG. So when they promulgated this SDGs, they had said you should not utilize fossil fuel beyond a certain limit. You should look after the oceans. You should look after the groundwater. You should look after trees and plants. Like that, they had set so many issues in sustainable development goals. And every country was required to develop their economy within this advice which has come. And one of the advice is reduce carbon emission. One of the advice. So there are many sustainable development goals. I'm not going into that in detail, but that's how all countries are progressing today, their economy. So one of the ways of following sustainable development goal is to adopt bioeconomy, where you utilize resources available in land or in sea and use them instead of a non-renewable item. You bring a biologically available renewable item in lieu of a non-renewable item. I told you some examples as well. It can be for industry, it can be for agriculture or services. But you need to develop some technologies to use it. And those technologies are called biotechnologies. I'll be referring to that as BT in my presentation. Why is BT so important? It takes care of environment. It is easily adaptable for circular economy. Circular economy is you can recycle it, you can renew it, etc. Advantages. And there is a human-centric approach in BT for various applications, but mostly for healthcare. We'll touch upon this a little later. So India had a dedicated department of BT in central government in 1986 itself. But somehow, many applications in BT did not get developed. The labs were functioning independently. There were a lot of replication between one lab and another lab. The outputs were not being coordinated well. So these biotechnology department has not grown very well, as well as the technology also has not progressed till early 2000. In early 2000, a lot of changes took place and the BT activities got more formalized, especially in the last 10 years, resulting in very good contribution to GDP. Today, government has issued a new policy called Bio E3 policy, which we'll talk about. But the focus is on 3 E's: economy, employment, and environment. And this policy has been structured in such a way to give focus on E3. With this, I'll go forward. So what is bioeconomy? I've already introduced to you about this bioeconomy. You make sure that you use resources from land and sea, which are biological in nature. And with the help of a BT, biotechnology, you utilize it and thereby don't use the chemical resources which is normally used. For example, cotton, which is available from the trees. If you use cotton for your dress, it's a part of bioeconomy. So you're using a biological resource. But don't use polyester. Polyester is based on chemical. The source is chemical. So don't use it. So focus is shift more to biological resources. Now, bioeconomy also has got subsectors, which is bioindustry, bioagriculture, bio services, etc. And another example I'll tell you is biomass. Biomass, which is the waste of, let's say, trees and plants and other things. There are many waste to wealth centers where biomass is burned, the gas produced is making a generator run and produce electricity. In such cases, the output is energy, just like as if it's coming from a diesel generator. But you're not using diesel, you're not using petrol. Instead, you are using waste, bio-waste, to produce this energy. So that's another application of bioeconomy. And as we go along, we will see that bioproducts, be it in agriculture or in industry, they have very small carbon footprint. Therefore, it helps in carbon emission control. So it is clear now in India that we need to adopt bioeconomy as much as possible. And for every application, you may require a new technology to be developed. So technology has to be developed. Applications have to slowly shift to bioeconomy. And we will see how it is going in India now. So these are the 17 sustainable development goals. I'm not going into details, but out of these 17, if you notice, 11 are supporting bioeconomy. These arrows are essentially saying they are in support of bioeconomy. 11 of them are supporting bioeconomy. And so therefore, every country, if they shift slowly to bioeconomy, they will strengthen the fight against climate change. Because that is of supreme importance world over, that we need to fight the climate change, which is affecting all of us all over the world. So bioeconomy is one route. There are many things to be done, but bioeconomy is one route. As I told you, bioeconomy can be further broken down to bioindustry, bioagriculture, bioservices, etc. And you need to develop the technology. So these biotechnologies world over has become so popular that today it is recognized by its color. I will just tell you, there are how many types of biotechnologies now defined world over. There are these 12 types of biotechnologies are there. In this diagram, there are only 10, but there are more actually in the list which I'm going to show to you. So if it's a red biotechnology, it is medical. Yellow is for food, blue is for marine, like that, green is for agriculture, so on. If you want to develop something which is to be required in desert condition or arid condition where there's very little rainfall, then it's called brown biotechnology. Purple is for documentation and patents. White is gene-based biotechnology. And that is where today cancer treatment is progressing. I'll touch upon this as we go along. Gold is for bioinformatics. Gray is wherever you use fermentation, using the bacteria which is there in the biological resource, then that biotechnology is called gray biotechnology. These are the color coding today world over, which has been accepted. And orange is for all the R&D, documentation, human resources, the training, etc. And the last one, I'm sorry. And the last one is black. When you use bio warfare, like everybody in the world at some time had thought COVID was a warfare by some country. The vaccines which we developed combated the bio warfare. That's what people were thinking. So there is a type of biotechnology dealing with warfare functions when you use biological weapon. We're not going to discuss all that. We're just going to say that there are many types of biotechnology and they are recognized by their color. That you need to know. And if it's a black biotechnology, it is warfare. And if it is red, it is medical. I think these two are the most important in that list. So I come to what are the advantages of biotechnology? One is healthcare has become very different now. Apart from developing vaccines for various type of protection of human beings, healthcare has become very, very precise. There is something called precision medicine. There's a new therapy called CART, where you are able to utilize newly developed cells injected into your body to fight your cancer. And of course, it is a little expensive to follow this treatment, but this treatment has already started, even in India. Tata Memorial Hospital in Bombay is the first hospital which has started it. So if you have got a cancer, suspected cancer, They will find out what is the type of cell which is causing this, and they will evolve, they'll create another cell which is similar, and it will be injected into you, and you'll fight the cancer. And the success rate has been fairly good. But to develop all this, you require good laboratories, good technologies, and it is expensive. But in India, it is relatively cheaper than other countries. Stem cells research, tissue engineering, all have been possible through biotechnology, especially for tissue engineering. Is basically you have suffered a burn, you have got severely lost your limb, and the skin has got completely damaged. Then you are able to regenerate the tissues using certain technologies which come under biotechnologies. Genetic modification of seeds. You must have all heard about BT cotton, biotechnology cotton. The BT cotton, which has got internally strength to fight against pests and insects by some method. So this has been another way of increasing your agricultural produce without losing them to pest, and therefore also consuming less pesticide. Otherwise, a lot of pesticide chemicals are used to protect your plants. Now that is reduced. The plant itself has got the internal strength to withstand any attack by pest through this genetic modification, which has taken place definitely in case of cotton, just happened. Environment, sustainability, cleaning up pollutants. Something called biofuel. I will explain to you a little later what is this biofuel. But the biofuel has already come to India, and it has started being distributed to petrol pumps, not in South India now, but mostly in Eastern India. And I will touch upon this as we go along. And it has been able to fight against the climate change, as I told you earlier. Apart from, is also increase employment in many sectors relating to biotechnology. It could be for research and development, it could be for manufacture, it could be for data collection, analysis, etc. So let us look at what is India's status on bioeconomy. You look at this graph. In 2013, our bioeconomy market value was $11 billion. $11 billion. In 2023, it is 150. So we have made a huge jump in the last 10 years or 11 years to make sure that we are able to increase our bioeconomy portion of our overall GDP. As I told you, $150 billion is roughly about 12 lakhs, little more than 12 lakh crores. I'm not taking today's exchange rate for this, but 1 minute. Right. Bioeconomy, economy, which is knowledge-based, accounts for 4.25% of India's GDP. India's GDP, about 4 to 4.25% is bioeconomy, and examples I have given you about this. And about 33 lakh persons are working in this. Now, in this bioeconomy, within bioeconomy, bioindustry is 48%, biopharma, all the pharmaceuticals which produce your medicines, they all are part of bioeconomy. There's 35%, agriculture is 9%. So we'll see what is it about. So let me take industry first. If you look at industry, there are 9 products which are very important. The 31% maximum is alcohol. All alcoholic items which we generate in the country, they are all from fermentation of some biological resource. It adds bioeconomy. You may not have thought about it earlier, but the biggest bio-industry item, which is 6.12 lakh crores, is 31% of it is alcohol. The second is poultry feed or aquaculture feed, which is again generated from biological resource. Then comes textiles, which is from cotton, I told you. It can be silk also, because from silkworm. leather, which is coming from leather of different animals, biofuels, I'll touch upon this a little later, baking and dairy products, all a product of biofuels. So bioeconomy, actually you are aware of many products of bioeconomy, but now I'm putting them in the umbrella of bioeconomy, saying alcohol, poultry feed, baking, dairy, etc., vegetable oil, etc. So let me now go to biopharma. In biopharma, 36% is medicines, 29, almost 30% is vaccines. And then you have medical devices which are made using biotechnology. So they are also considered under bioeconomy. And that is about biopharma, which is about 4.2 lakh crores. Bioagriculture, 79%, almost 80% is BT cotton in India. Cotton production has increased so much after they have started using BT seeds, which, as I told you, has got inherent strength to withstand the attack by pests. Then you have biofertilizers. You may recall about 7-8 years back, we started tipping or coating our fertilizers with neem oil. Neem oil was used to coat fertilizers. And these fertilizers were used by farmers. And these fertilizers were put in the soil. So from the roots of the plant used to absorb the fertilizer, which had a neem coating. And that neem oil, which was absorbed by the plant, made it resistant to pests. So you made biofertilizer to make sure that you don't use much pesticide, number one advantage. Number two, the plants became inherently strong to withstand the pest. So that is one application in bioagri. Similarly, there's biopesticide and bioalternatives. Bioalternatives are so much about producing an alternative which is equivalent to what is that original product. We will touch upon this as we go along. So you find, and there is bioservices which deals with IT and data collection and analysis, etc., including clinical trials. When you do biotechnology, you produce a new medicine, you want to do trials, that comes under bioservice. Bioeconomy, which is 4.25% of India's economy, $150 billion as of 2023, has got subsectors of industry, pharma, agriculture, services, etc. So but of course, we need to look at what is driving them. Essentially, it is R&D by scientists. It is essentially R&D by scientists, which the government has now done an addition to it, which I'll coming to it in the next slide. So major Indian products are, first is vaccine, I told you. Second is producing ethanol from sugarcane or grains or corn. They are crushed, and from there, after fermentation, ethanol is made. And this ethanol is blended with petrol. Today, petrol blended with ethanol at 14% is being sold in eastern part of India. And slowly it'll come all over the country because there's only one plant which is doing this blending and mixing at this point of time in eastern India. And some more plants are being converted for this blending operation. Similarly, they're going to blend diesel. At the moment, is under trials. So if it finally comes to 20%, which is the target, imagine 20% of your petrol will be substituted by ethanol coming from sugarcane. So you have to import less petrol, less crude oil. You don't require to import so much of crude oil. 20% will come from ethanol, which is coming from sugarcane, which is biological resource within the country. So it can be not only sugarcane, it can be corn, it can be grain, etc. This is a very important product which has come in bioeconomy, and the trials of cars and trucks running. There are not many trucks running in petrol, but cars and other two-wheelers running on bioeconomy on ethanol blended petrol has been satisfactory. Similarly, they are trying to develop fuel for aeroplanes called sustainable air fuel. You all know that aeroplanes use kerosene, which is called aviation category kerosene, which is being used. Now, they are trying to blend air fuel also to generate air fuel which is suitable. And this development is going on in Indian Oil. Maybe in another 2 years' time, we will have this newly developed air fuel for aircraft. It's called SAF, short term. And it is likely to be, and world over, this development is going on in many countries to make sure carbon emission is reduced. Then another major important product, as I told you earlier, precision healthcare. That means you develop a drug which is of the correct composition for a particular category of group of patients, rather than having a generalized medicine which is given to the patient. This will become exactly specific to the patient's requirement. This is possible through biotechnology now. I talked about gene therapy. And India has also completed the Genome India projects on 10,000 persons all over India to get our profile, gene profile of Indians. Some are from South India, some are from Western India, some from North, some of this, so that you are able to have a database on the profile of India's Indian population. Biofertilizers and pesticide, I already talked about. Many of the fertilizers, you have, when you go to the supermarket, you find a lot of organic foods which are not using chemical fertilizer, which are using biofertilizer. Biofertilizer means what you use to generate vermiculture. Through that method, you generate fertilizer and then you use it for your farming. Now, this is another product of bioeconomy. And similarly, biosimilars are being developed for certain organs which have to be replaced, either because it has got a cancerous growth and therefore it has to be changed, or because of diabetes, you require that organ to be replaced. So today, biotechnology has been able to generate these organs compatible to a living patient. So let's look at how is it happening globally. Globally, USA has got the highest output in bioeconomy. But if you look at the percentage of bioeconomy with respect to their GDP, it's only 5%. Then comes China with 4%. But if you look at Germany, Japan, France, Italy, UK, Spain, all of them have got bioeconomy percentage more than 10 to 15 in their country. They're using so much of bioeconomy products within their country. As I told you, India is at 4%, 4.25% to be specific, and Brazil is at 7%. So India is in the same league as USA and China as far as percentage is concerned. But if you look at the total bioeconomy value, as I told you, is $150 billion, and we are the 9th in the world today by the value. Percentage-wise, we are at 4%. So India needs to catch up a lot. It is expected that in the world, there is 105 trillion of GDP now, world over, all countries. And if you look at the world over, the percentage of bioeconomy is only 3.8%. So India is slightly above the world average at this point of time. I talked about EU countries which are having very high. USA, China, Brazil, India, all less than 10%. So India is at 4%, as I told you earlier. Now, what are the initiatives by government recently? These are the many places where biotechnology is being developed either by a proper lab or by a startup. And I'm coming to startups a little later. Government has formed 9 bioparks in India, and 74 specialized bio incubation labs have been created in various places, including about 6 of them in northeastern states. Majority is on Western India, Northern India is the majority. Now, these bioparks and these bio incubation labs have been able to attract a lot of startups where they have been able to develop new technologies required for bioeconomy. The second initiative which government has done is there were about 15 institutions all over India which were dealing with biotechnology. So government brought all these institutes under one public sector called BIRAC, which will be the umbrella organization for all of them to make sure there's coordination, there's no duplication in work, and also exchange of data, also making sure results are shared. Therefore, we're able to move forward in a much more efficient manner. Government has recently promulgated, not recently, modified the IP rights policy. It was issued in 2004, but they have recently modified it. They have started PLI, Production Linked Incentive. This has been started for certain drugs, certain components of drugs called API, active pharma ingredient. We used to import a lot from China, API for our normal medicines. Now India started making APIs slowly for many drugs. So we are able to make the drugs with Indian API and medical devices, many medical equipment they have started making in India. And all of them have been given production linked incentive, which has enabled their production to increase, bioeconomy component has increased, and that's how we come to $150 billion. 8,000 startups are there in India today, only in the field of biotechnology. And they are finding alternatives which are environment friendly, so that the present products which are based on use of chemicals and other type of material, they can be substituted with biological resources, so that using suitable biotechnologies. As I told you, 10,000 genome project we have just completed about 3-4 months back. And we have created a portal under BIRAC, by which you're able to give approvals to startups, give financial sanctions to startups, by which they are able to monitor the progress of their research and thereby get them coordinated and make them a good teamwork exist in the biotechnological field. Now, there are some challenges, of course, in biotechnological field. First is biotechnology itself is a complex technology which needs to be developed, making sure it is safe, because you obviously, before you administer to human beings, you will do the trials. If it is something related to food, you have to do extensive trials. Public perception has to be controlled, has to be moderated and modulated towards this product which is being developed through biotechnology. And normally it takes about 10 years for it to come out. Today, when you go to supermarket, you will understand what is organic food, what is organic dal, what is this. You understand very clearly, which was not the case about 7-8 years back. Now, slowly the public has started appreciating, and they really feel that all these are good for not only for their own nutrition, but also for the environment. Funding our projects, it's a challenge for the government, but they have been able to do it through this umbrella organization. And therefore, because all biotechnological developments are high risk and high development, So their funding has to be also of an appropriate scale. There have been lack of trained manpower in this area. So government is putting in some efforts to make sure a lot of biotechnology institutions are coming out with well-trained trained and educated people on the subject, and they will try to get them employed within the country to make sure. So if you look at Bio E3 policy, 1E pertains to employment, and that is to tap the potential of all these students or graduates who are coming out of the various institutions. We're targeting it very, very closely so that we get the best talent into the biotechnological field and make sure jobs are extended to them. IT services and artificial intelligence has also been combined with the various developments which are taking biotechnology. IP protection, whatever you develop, intellectual property has to be protected, and sanction of patents had to be made sure. And they developed this new Bio E3 policy in August 24 to manage all these changes. So what is Bio E3 policy? Bio E3 policy is to make sure there is good manufacturing and you provide sustainable growth through biological resources. As I told you earlier, that is the aim of bioeconomy. So after all, we had to control our carbon emission and we had to reach net zero in 2070. And many paths had to be followed to reach net zero. One of them is through bioeconomy. So that is why the manufacturing of bioeconomy product, the economy part, is one of the important aspects of this E3 policy. Second is on innovation, R&D, and entrepreneurship, which I talked about earlier. And they will be creating biofoundries where very biosimilars are developed and manufactured, and bio-artificial intelligence hubs. Workforce will get expanded. As I told you earlier, one of the E's regarding employment. So you try to get all the talent from various institutions and make sure they are able to either pursue entrepreneurship through a startup route, or they are getting absorbed to work in the various institutions so that biotechnology development is at a higher speed in India. And also aligning the citizens to live for environment, take care of environment, because that is a very important aspect of Bio E3. Now, this Bio E3 which has come, it can combat climate change, as I told you earlier. It can meet nutrition challenge because you're coming with food which are able to protect itself, it's got a strength, as well as there's no wastage because of pest having eaten away the. So that way, your nutrition challenges as well as food security is taken care of, lower carbon footprint and lower water consumption. These are the important aspects in the Bio E3 policy, which will come. As I talked to you about, gene therapy and cell is an important issue for personalized medicine and monoclonal antibodies, which are being developed. Food security, I talked about through agriculture, climate change, and there are some requirements for space missions. We are going to send our astronauts to space in a couple of years of time. So what is required for them while they are in space, they have to be developed through biotechnological means so that they are able to survive during their space mission. Similarly, for deep ocean mission, which will be an activity pertaining to sea mining, which is going to happen very soon, another year or so. So there also you require special bioeconomy products which will support space and deep ocean missions. So with this, I come to the topic, the last topic. What will be in 2030? How will it look in 2030? In 2030, it is expected there will be 35,000 startups in India by 2030 because it is picking up speed and they have made planning for making sure supporting so many startups and also giving them a lot of financial incentive. And the budget, ongoing budget, government has allocated 2,250 rupees for biotechnologies to be developed. Startups, I told you, presently it's 8,000 something, it will go to 35,000. And biopetrol with 25% blending will come out. Biodiesel may also come to 5% by 2030. This will reduce our imports significantly. And also the sustainable aviation fuel, which will see anything up to 5% blending, will also come by about 2030. PLI scheme is expected to enhance production in medical equipment, APIs, and common drugs which are required for India's population. And there would be increased convergence, biotechnology plus digitalization and engineering, which will make bioeconomy to grow. This sort of coordinated action had not taken place earlier. Now it's going to happen. Biotechnology plus digitalization and engineering. So in conclusion, or is it some 2030, we will go to $330 billion. And the biomedical will be more than bioindustrial because it is expected that we will make a lot of medical equipment in India. Our GDP is likely to be 7.3. And bioeconomy at 330 will be still 4%. We are not, the percentage of bioeconomy is not growing, even though bioeconomy is growing, but GDP is also growing. So it will still remain around 4%. Employment will increase significantly. And we will be in the category along with USA, China, etc., while the European Union countries are expected to go up to 30% to 35% by 2030. So in conclusion, I say that bioeconomy route has got a triple advantage of low carbon footprint, adaptability to circular economy, and being humanity friendly, especially in healthcare. Because biotechnologies have produced many wonderful drugs. They are promising to bring new types of therapy, gene therapy, and all this is going to benefit a large percentage of people who are otherwise afflicted with very serious cases which are likely to cause morbidity. The economy of tomorrow has to be based on plants, animals, and microorganisms. That's how the trend is coming in. And bioeconomy activities will, in India, may reach nearly $330 billion. Now it is 150, and it may go up to 330. Of course, EU nations will do much better than us, but we will be along with China, USA, and Brazil. As I told you, they formed an umbrella organization called BIRAC, which has been coordinating amongst all the biotechnology institutions. Startups have been promoted. PLI for manufacturers has been created. APIs have been made in India. Medical devices are being made in India. BT modified crops are being generated. And so far we have reached around 12th rank in biotechnological applications. It is expected that it will grow further, especially in areas pertaining to ethanol blended fuels, gene therapy, how to capture CO2 from atmosphere, and various requirements of the space and deep ocean missions will get developed will get addressed by biotechnologists, and will support these activities in the years ahead. So the B3E policy is bringing employment, environment, and economy altogether, the focused application with biotechnology, digitalization, and employment to make sure that our biotechnology grows to $330 billion by 2030, but we'll be still at 4% of our then GDP, which is expected to be 7.3 trillion. So biotechnology is going to be the economy of tomorrow. Biotechnology is going to drive the economy of tomorrow by making sure we all depend on biological resources, be it from land or be it from sea, plants, animals, marine life, microorganisms. All these are going to be tapped to make sure we develop new products which will make sure that life on Earth is sustainable, more sustainable as the years go by. It got threatened by climate change. It is trying to be reversed slowly by following a bio-E route, which has got low carbon footprint, which has got adaptability to circular economy, and of course, making sure world over the population is given better healthcare. With this, I come to the end of my talk. Jai Hind.